So 5G-Xcast is a project of phase 2 of 5G PPP, and in our project we have focused on some capabilities that are actually missing in the first 3GPP releases of 5G, and it is the possibility to transmit multicast and broadcast content. So currently 3GPP releases are focused on unicast. So in our project we have designed and tested the capabilities that would enable multicast and broadcast in future 5G releases. So beyond design of the architecture, the core and the physical layer, we are also testing, and here at EuCNC we are presenting 5 demos. 4 of them are focused on media and entertainment, and we have also one else from public warning services. This demonstrates that in the end, multicast and broadcast capabilities are essential functionalities that should be included in future 5G technology and 3GPP releases in order to provide network offloading, provide the ability of transmission of TV and radio services over 5G networks, and also, for instance, something very important, to alert massive audiences about emergency situations and catastrophes.
Hello, my name's Joe Isles from the BBC R&D department. The demo I've got today is called Forecaster 5G. It's a weather forecasting object-based app. So what we've done is we've taken a standard weather forecast and we've split it up into a number of objects. So we've got the video of the presenter, video of a sign language, and then a number of objects for the background weather map. And these are getting delivered to the device where they're being rendered. So we're delivering the large bandwidth heavy objects and also the objects that are common to almost every user over multicast, and the personalization objects and the smaller, less bandwidth intensive objects over unicast. The multicast is getting delivered by a system that we developed in the BBC R&D department called the Dynamic Adaptive Streaming over IP Multicast. So what this system does is it receives multicast and outputs unicast, which is then delivered to the devices. It also, as it receives the multicast, if there's any errors or any drop packets, then it uses unicast to patch this. The idea is that we put this system as close to the edge as possible, perhaps at the edge of the 5G core, and thus we would get the biggest savings from multicast with just a small overhead of this unicast patching to fix any errors. So to conclude, we have a better user experience from having this object-based approach, which gives a kind of interactive effect, whilst also being able to deliver it at scale over IP using this multicast.
Hello, my name is Menno Bot and I'm working for One-to-Many. I'll be presenting to you a demo about Multimedia Public Warning. The Multimedia Public Warning demo is a project under the 5G-Xcast, and it is made jointly by LiveU, Fair Spectrum, One-to-Many, and the Turku University of the Applied Sciences. We want to send multimedia because the traditional public warning systems are only text-based, and with multimedia we have the ability to send more rich information, including audio, but also pictograms describing what people should do in pictures instead of words, as well as additional pictures of the area that is having the disaster and what type of the disaster is. However, with multimedia, these messages can be very large and they take a lot of load on the network. So in this demo we have implemented several methods to reduce the load of the network, which includes dynamic spectrum allocation, which will be shown here. So we automatically set up a network, which is done by Fair Spectrum. We also have a LiveU device, which does channel bonding, and it will make this information available through Wi-Fi to this set of phones. And it will use multiple modems, including the channel that will come here. I'll send the alert message right now. Now the public warning system made by One-to-Many will send the message to the Fair Spectrum system, which creates the network here. And within 20 seconds, these phones, and after 30 seconds, these phones should receive the public warning message.